So the first lot of questions that I want to be looking at today is just basic expanding. So this is the first 4 questions on page 1 of your booklet that I've given you guys. So as usual, guys, I'm going to give you guys about 2 minutes just to try these questions out. I'm not going to give you guys more than 2 minutes because, to be honest, some of this stuff you should have done way back in year 10 or 9. But I'll give you guys 2 minutes. So off you guys go, yeah? Whenever we talk about expanding, we're talking about removing the brackets. So the first step is I've got to go 6x times x, which is going to be 6x squared, and then 6x times minus 2, which is negative 12x. All right, that's first one. With the second one, we pretty much do the same thing. So we got 3 times x, which is 3x, and then 3 times 4, which is 12. Now, this is where I've seen most people make mistakes, is in that second part. See, you've got negative 2, which means you're actually doing negative 2 times x, which would be negative 2x, and then negative 2 times negative 2 is plus 4. Once you get that, you've got to add your like terms. So in this case, 3x and minus 2x is a like term, 12 and 4 is a number, so it's a like term by itself. So we've got 3x minus 2x, which is 1x, and then 12 plus 4 is 16. Now some people have asked me this question, would I be correct if I write it as 1x? You're absolutely correct. There's nothing wrong with it. But in maths, generally speaking, if you write x, that means that it's 1x. All right? So you don't have to write 1x as is. So that's what that is. Going to question C, we've got a quadratic. Now, with your quadratic, I've seen so many different ways of people doing it. Whatever you feel confident in working for you, that's fine. Just go with it. We don't care what method you choose. Like some people have used little tables, some people use FOIL method, some people can just look at it and just solve it. All right, and that's fine too. So it doesn't matter which way you go with it, as long as you know you're confident that you can get the right answer. So what I'll be showing you guys here is just the FOIL method. So the first, so you got x times x, which is x squared, and then you got x times negative 7x, which is, negative 7, which is negative 7x, and then 2 times x, which is 2x, and then 2 times negative 7, which is negative 14. So once again, we do our like term. And in this case, we've got negative 7 plus 2x. So that means we've got x squared minus 5x minus 14. All right. Now, when we are looking at question D, another common mistake that I've seen people do is they write this as p squared plus q squared. Now, if you're one of those people that actually did that, then you're actually incorrect. Okay? Whenever you have a squared or a cube or whatever with the brackets, it's a really good idea to write them out like this, because that's what p plus q squared is. Once you write them out, then you can actually expand the brackets. So you got p times p, which is p squared, and then p times q, which is pq, and you got q times p. Now q times p is the same thing as saying pq, okay? And then you got q times q, which is q squared. So putting it all together, we look at our like terms. In this case, the pq, there's 2 lots of pq's, so we're going to write that as p squared plus 2pq plus q squared. So as you guys can see, that 4 questions there is worth like 5 points in this test. But that's because the last question is worth like about 2 points. Because as I said, most people end up doing this right here. And then that's where they kind of lose out the mark. Okay, let's go to the next page. We're going to start looking at factorizing. Yeah, we'll share this notebook with you guys. Now, like I said, guys, this notebook is live on your Google Classroom. You can go and have a look at it. When you launch the page, you will end up to this particular, so it'll look like this when you launch the page. Just click on Maths 1. If I click on it, is it not going to go? Where's my touch? There we go. Nope, that ain't working as well. I need a mouse. I don't have a mouse. Sorry. Just go into Maths 1, and I think if you go into Maths 1, it goes to Topics, and then you can go to Topics. Under Algebra, I think there'll be like a Tuesday session coming up, but you can't see it on the side there. That's the today's session that we'll be working on. Okay, I will add that up later on. We go to the second part, guys. So second part is all about factorizing. So I'll put the questions up very shortly and then give you guys a couple of minutes to give it have a go, and then we'll go through the answers after that. All right, guys, I'm hoping that you've had a chance to go through some of these questions, but I'll go through the whole lot at the moment. All right, yesterday when I was actually showing this to my other class, I kind of just probably rushed through it a little bit too fast, but I'll try my best to actually try and get as much of the message through. So with the first one, when we're talking about factorizing, we've always got to put them into brackets. All right. So when you look at these two numbers here, you got 20 and 32. You want to look at what's the lowest common factor that you can actually take out. Sorry, not the lowest, highest common factor. So you know that both of those numbers can be divided by 2. You also know that the numbers can be divided by 4. Now, anything higher than that, I don't think it's actually possible. So that means you're looking for the highest number that's common between them that they can be divided by. So you know it's 4. So what you're going to do is you're actually going to take 4 out. But if you take 4 out, what you want to be doing is you want to go 20 divided by 4 and 32 divided by 4. So 20 divided by 4 is 5. Nothing happens to the x. It just stays as is. Plus, and then 32 divided by 4 is 8. All right, that's probably the best way I can describe it, and I'm sure that other teachers around the world probably do it in a slightly different way as well. But yeah, that's the way I kind of see it. Yep, go on.
What happens if you use 2?
That's a really good question, because if you use 2, you're going to end up with 2 10x plus 16. But this is not the lowest. You can actually do it further, right? Because 10x plus 16, if I write down 10x plus 16, you can actually take another common factor of 2. Because you can rewrite that as 2 5x plus 8, right? And remember how you already had this 2 outside there, which is going to be outside here. And that's how those 2 multiply to equal 4. All right? So yes, you've factorized it partially, but not fully factorized. And that's what you need to get into the habit of. All right? So always, when you finish it, look at the numbers and go, well, can I actually break it down any further on? Okay, so that's number, I guess that was A. Going to B, and I guess I kind of use that similar tactic here as well with B. I look at 18 and 30. What's the biggest number I can actually use? It's got to be 6. But, you know, I will understand if some people decide to go with 3. But remember, if you use 3, I reckon you can actually break it down further. So 6 is the number I'm looking at. So that means I got to go 18 divided by 6, 30 divided by 6. Okay? So when I go 18 divided by 6, that's 3. And then 30 divided by 6, that's going to be 5. But I've also got all these letters there. I've got P and Q. Now, I can actually look at what's the lowest, like what's the highest common factor between them. So I'm going to put a 6 here. So what I want to be looking at is between P squared and P, the highest common factor is just P by itself. So I can actually take P outside of the bracket. If I take P outside, then I'm going P squared divided by P, P divided by P. So P squared divided by P is just P. P divided by P is 1, so I don't have to worry about it on the other side. And then when I look at Q, I've got 1Q and I've got Q4. So the highest one is Q. So I'll take out Q outside. And then Q divided by Q is just 1. Don't have to worry about it. Q4 divided by Q is Q cubed. All right. Now, I'll bet you guys, if you actually watch Miss Nedden's video, it might be explained in a completely different way. All right. And that's all right. As long as you can figure out how to get to that final answer, whichever method you use, it doesn't matter. As long as you fully factorize it towards the end. Okay. Having a look at C. Now C is a quadratic, so basically you are looking for two numbers that is going to multiply to positive 5, and the same two numbers also have to add up to negative 6. So I'm going to kind of go through it real quickly here. Negative 5 times negative 1 is positive 5, and negative 5 plus negative 1 is negative 6. So that means this is going to be x negative 5 and x negative 1. All right. When we look at question D, the x squared minus 81. Now this is actually known as difference of two squares. All right. This one is always going to look like this. You always, whenever you get x squared minus 81 or any square number, you just take the square root of 81. In this case, it's 9. So you chuck a 9 on both ends, but put a plus and minus in the middle. Okay, that's what difference of two squares is. And as for question E, has the same kind of idea. Because if you look at question E, 16 is a square number, a squared is a square number, 25 is a squared number, b squared is a square number. So what you have is you've actually got 4 square numbers there. So 16, when you take square root of 16, that's going to be 4. So that's going to be 4 and 4 there. A squared, when you take square root of a squared, that's going to be a and a. Square root of 25 is 5 on one bracket and 5 on the other bracket. And then when you take square root of b squared, it's just going to be b and b. And then don't forget, one of them will be minus and the other one will be plus. Okay, so the final answer you should get is 4a minus 4b and 4a plus 5b. 4a minus 5b, I should have said. Okay, now that's dealing with some really big difference of two squares. And the last question that I want to do with quadratics is this one here, guys. I want to know how many of you are comfortable factorizing this, just even a show of hands. Okay? Very confident? Sort of. Okay, now considering the time here, I've got two options. I can actually show you guys a particular method of how it will work out. Or if you are planning to do maths next year, I can show you this particular formula, which I know people have seen it before in Mission Heights and possibly in the other schools as well. But if not, this one formula will help you guys out throughout if you want to carry on with maths at level 2 or level 3. All right? The only issue is you will have to remember the formula. But the thing is, if you do it enough practice, trust me, this formula will help you with the other aspects of this paper as well. Because I think when you get to page 7, all of, especially the top 3 questions in page 7, you can actually use this formula and it actually works out. I'm going to give you guys the formula. It's called a quadratic formula. All right, it looks like this. Take it down, and I'm telling you guys, it looks complicated right now, but you do like about, say, 20, 30 of these problems, it actually becomes really easy. So the formula actually looks like this. The quadratic formula. If you remember it, awesome. If you don't remember it, practice and you will remember it. All right, so this is the formula that I generally tend to work with. I would say if you can remember this formula, you pretty much can solve quadratics, solve quadratic equation, or even factorize quadratic equations. Okay, because there are a couple of little tricks that I show people that is extremely useful. So if you, I don't think you might have actually done this before, but basically what you do is you write down ax squared plus bx plus c. All right, that's step number 1. Step 2 is you match your ABCs. So in this case, A is equal to 2, B equals minus 1, need another colored pen, black, and C equals negative 6. All right, that's the first step. Once you get that, the next step is to actually take all of these three things and put it in this equation. So what you're going to end up with is x is equal to, now you got minus b, so this one will be minus, because b is equal to negative 1, we're going to have a negative 1 like that, plus or minus b squared, so it's negative 1 squared, minus 4 times a, which is 2, and c, which is negative 6. And the whole thing is divided by 2a, or 2 times 2. It's a bit of substitution there. Once you do that, guys, the rest of it is just straightforward, because you've got negative and negative 1, which makes plus 1, plus or minus. Negative 1 squared is 1, and then you got negative 4 times 2 times negative 6. That is going to be plus 8 times 6 is 48. And then 2 times 2 is 4. So what you're left with is 1 plus or minus square root of 49 over 4. Now this number here, this number should always end up being a very nice number, like a square number. Okay, if you don't get a square number, you probably have done something wrong. But believe it or not, this actually works. This will help you guys in lots of, couple of other ideas as well. So from here, we've got 1 plus or minus square root of 49 is 7. So we got 1 plus or minus 7 over 4. That means your two answers for x, the first one is 1 plus 7 over 4. And then the second one is 1 minus 7 over 4. So your two solutions is you got 8 over 4, which is 2. And then here you got negative 6 over 4. But you want to make it, you want to simplify it as far as you can. It's going to be negative 2 over 3. Have I got that right? Or no, sorry, that's negative 3 over 2. So those are your two answers, right? But you've got to put it back into brackets. So if I go back here, I've got one of my answers, x equals to 2. And my other answer was negative 3 over 2. So here's what you have to do to get you just have to rearrange so x is like zeros on the right hand side. So in the first part, I'm going to go x minus 2 equals 0. And in the second one, I'm going to cross multiply. So I got 2x equals minus 3. And then 2x plus 3 equals 0. And right there, guys, we got our two factors. So that's going to be x minus 2, 2x plus 3. So what we've done is we've factorized this. Now I know it looks long, it looks, like a lot of work, but trust me, that's what you're required to do. But if you get it right, if you practice it enough, 100% of the time you'll get the right answers. You don't have to do the guessing and checking. You don't have to do partial, like splitting it up into 2 and factorize. This will always work. This is handy to you. And all you have to do is literally remember that formula in that yellow highlighter box. And if you practice a few of them, you will nail it. So remember, guys, there's lots and lots of little skills that you need to learn. So even if you don't understand one skill, you got to try and learn all these other ones. And eventually, after you practice enough of them, they'll all start connecting. Okay? They will take time. Okay, so we're going to go to page 4 now and do that lot of questions there, which are, again, you guys should be able to do some of them. I'm going to write the questions up, my versions, and then we'll go through it real quickly, guys. All right, guys, for this section, I'm going to give you guys about 4 minutes, all right, and then I'll go through the answers. So I asked you guys to simplify in this case, so all you're doing is looking for like terms. In the first one, you've got y and 2y as a like term. So when you combine it, you get 3y minus 3x squared. That's basically it. You could have written it as minus 3x squared plus 3y. That's absolutely fine. All right, so it's not an issue there. Now the second one, I know it looks very ugly, but really important to actually look at the powers. All right, so if I take the first one there, that's m squared, n cubed, and o to the power of 4. This one has o to the power of 3, the second one, so we're not going to count it. So only those two are like terms. So we can combine them together. Remember I told you in maths we don't write 1x. So there's actually a 1 right next to that, m squared n cubed over 4. So when we combine it, we're going to get 4m squared n cubed o to the power of 4 plus m squared n cubed o to the power of 3. So this thing that's highlighted in the green, we're not doing anything to it. We're leaving it as it is. And also notice, when you combine the two like terms, you don't actually add the powers together. Okay, you only do that for multiplication, not when you're adding. So I'm actually talking about this right here. So notice how the powers are the same at the top there. Okay, when we go to question C, that's when the powers get added up. The reason is because of this multiplication symbol. It's not being added, it's being multiplied. So if it's being multiplied, first thing is I've got m squared, I've got m cubed, and then I've got m by itself. So altogether, I've actually got 6m to the power of 6, because it's 2 plus 3 plus that 1 that's there in that corner. Then I look at the n. The n is cubed, squared, that's it. So that means I'm going to get n to the power of 5, because 3 plus 2 is 5. And finally, I've got o to the power of 4 and o to the power of 3, which is going to be o to the power of 7. So that's where that 7 comes from. All right, so when you multiply, that's when you add the powers up. But when you add like terms, you don't touch the powers at all. You leave it as it is. All right, question D. Has anybody got the answer for this? What? Thank you. Anything raised to the power of 0 is equal to 1. It's not 0. All right? So anything raised to the power of 0 equals to 1. You just leave it as 1. No matter what it is. It could be like a really big ass fraction or powers, whatever. Okay? So even if you have something like, I don't know how many ever zeros you want to put in there, if it's raised to the power of 0, it's always going to equal 1. Okay? Question E. When you have powers of powers, you actually multiply the powers. So in this case, it's going to be a to the power of 2 times 3 and b to the power of 3 times 3. So when you do this, you get a to the power of 6 and b to the power of 9. All right, one thing that I've seen people do, common mistake, I'm going to do E part 2, is this. When you have a to the power, ab 4 to the power of squared like this, always remember that just like how a letter has 1 in front of it, it also has a power of 1, but we never write the power of 1. Okay, so that means a, it actually has got a 1 as a power of it. So when we expand this, we're going to end up with a to the power of 1 times 2 and b to the power of 4 times 2. So we're going to get a squared and b to the power of 8. That's what it's going to look like. Now as for f, you got square root. Square root is just taking what's square root of 81, that's 9, and then square root of y to the power of 4. What you're doing is you're halving the power. That's what square root means. Square root means half the power. So if it's y to the power of 4, it's going to be y squared. Let me show you guys another example with f2. So if I have square root of 100, x to the power of 8, y to the power of 3. If that's the case, then you go square root of 100 is 10. X to the power of 8, now half of that is going to be 4. And then half of 3 is going to be 1.5. So the powers, when you take square root, you always go half of it. All right, guys, that's basically the 3 sections I wanted to work on today. Tomorrow morning when I see you guys, I'll go through the last few pages, and then we've got a little bit of the advanced stuff to do as well. Now, as usual, you guys got this booklet, so go away, go home and do the questions in here. Check the answers on YouTube, and I will go through more of these questions tomorrow.